Okay, now what I think I've seen at least some of you doing is going to the third picture immediately. And that's okay, that would be natural. Okay, I would kind of expect you to do that. So the third picture would look like this. You've got the original wave here. Still moving to the right. And it's moved this far, right? And then your reflected wave is going to, what color am I using for the reflected wave? Oh, green, yeah. Got too many colors going on here. Your reflection of this wave is going to be on the other side, right? Okay? So it's going to be coming back this way, giving you this, right? Okay? Now, between this and this point here will have just moved a quarter of the way, right? So we'll just mark this at a quarter of the distance, and we'll mark another one at a quarter of the distance here, because this one will have moved to here, right? And these are the points where this wave will be 0, right? Okay, then what's that going to look like? Well, you got to start down here, and you have this, and you're going to have this, right? Now your reflected wave is coming back, okay? And of course it's going to come back, it's going to be on the other side. Of course, it's only had time for this much of the wave to have reflected, right? Make sense? So what's going to happen is, here the wave is going to flatline, but here it's just going to match this one. Okay? It's going to come up like this, then it's going to flatline. Now actually, in this case, you have a discontinuity, and you really can't have that. At least I don't think you can. Your function wouldn't be differentiable anymore at that point, because your slope suddenly changes, right? You'd have a discontinuity in your derivative, which kind of offends me, but I'm not worried about it, because this transient state is going to pass very quickly once you've had a couple of reflections, right? Okay? So let's see, this state actually isn't going to occur until somewhat later, at the time this thing has had a chance to reflect all the way back here, right? So in between here and here, you got extremely transient states that we're not really going to worry about. All we're worried about is what happens after this thing has been gone for a dozen cycles or so. Okay? So assuming now that it's been going on for that long, you're going to get this state, right? Then we want to get the state where it flattens out. And if you keep moving the wave this far each time, it's never going to be flat. Okay? So we've got to move it half of an arc at a time to get the flat line. So, just to see, what happens next. Well, this is going to move to where it's wrong color. To where its 0 point's going to be here, and it'll have another one here, because this point will move to here, this point will move to here, and now you've got this. Then this point will move to here, so that, well, you're going to have I got to be getting a flat line. What's going on? Okay, well, okay, we're gonna do that. Okay? You've got these. We're also going to assume that you've got more reflections, okay? I'm not sure that's going to help, though. So it looks like, you know, okay, we're going to get a waveform that looks like this. Let's just accept that for the moment. Okay? Now, if these things move another quarter of a wavelength,
I think it would be at the end again.
Yeah.
then
So it's going to be the exact opposite from the beginning.
hopefully things are going to look the way I want them to. Okay? And you can see if you move another quarter wavelength, this thing's going to, of course, it's moving this way, right?
Wait.
Shouldn't it
I
be
thought
at the
the
end?
purple one was always going to the right. And the green one was going
Yeah.
to the
Yeah, purple one's moving to the right, and the reflected wave's moving to the left, sorry. Okay? So, this much more of this wave is going to be here, so it's going to look like this. Okay? And then the green wave will be here, so it's going to look like this. Right? Okay, so now you have the flat line. And then in the next picture, and I'll let you work it out, in the next picture, this will have moved over here, and this will have moved over here. So, well, whichever. Okay? And now they're going to line up again. Now, sorry, the green will have moved over here, and the purple will have moved over here, and they're going, well, okay, you work it out. I'm not moving it far enough, but what you're going to get is you're going to get something should be canceling here. That moves this way, this moves that way. This should be simple. You know, I didn't move my purple to the right, I moved my purple to the left when I did this picture. If I'd have moved it to the right, it would have canceled off. Okay? So I just didn't move it correctly. So anyway, you're going to get a series of pictures that look like this. You're going to have this followed by a flat line, followed by this, followed by a flat line. Okay? And then it repeats. The time it takes to go from maximum amplitude to flat line is the time it takes the wave and the reflected wave to move through half an arc of the sine. Okay? Now, since this wave, since an arc of the sine for this mode is only half as long as the arc of the sine wave for this mode, that means that these things are going to occur twice as quickly. The whole cycle is going to repeat twice as quickly. Okay?
So it's got twice the velocity.
No, twice the frequency. Because remember, your velocity is determined by the mass per unit length and the tension, which isn't presumably changing between the two situations. Okay? So, time for a cycle I said that time for a cycle is half the time. The time for each phase of this cycle. Each of the phases that I've drawn here is the time for half an arc of the sine function. To pass. And the period then of this motion is 4 times this, okay, which is the time for 4 of these half arcs to pass. Well, there are 4 half arcs of a sine function in one cycle, right? Okay? Now, we could have concluded this already, but we wanted to see how these cycles develop. And you should be able to do one for a wave where there are 3 arcs of the sine function. Okay? And I'll write a couple more general ideas up here.